we start recording, and let me maybe start, and I guess others will join as well. So we are very pleased to have a presentation today by Yegnanew, I hope I spell correctly, Shiferaw,
Yegnanew, yeah,
from University of Johannesburg. And this is our next ERSA seminar related to digital transformation and industrialization. As usual, as I said before, this seminar has as an objective to discuss each other's research, exchange ideas. So anybody that would like to present is welcome to send me an email, and we'll arrange presentation as usual on Wednesdays. So the seminar will be recorded. We have 45 minutes, and then there'll be some questions and answers. But if you have any questions in the meantime, then also feel free to ask. I guess that's fine, right? All right. Otherwise, I think we can start. Thank you again.
Okay. Thank you, Lucas, and welcome to seminar. Today I'm going to present about localized estimates of digital gender divides in South Africa. And mainly this seminar or this talk will focus on how different are men and women really represented in the digital sector. Specifically, that is an issue. So this is briefly the outlines of my talk. I'll briefly say about digital inequality, and I'll spend maybe 10 to 12 minutes on discussing some statistical methodologies and data sources and result in some discussion as well. So let's come first. What is digital divide? This term has different meanings to different people. This term became part of the researchers' vocabulary around 1995. So it's just started around there. So it's used to describe the uneven or unequal distribution of the ability to access and use information communication technology between individuals due to socioeconomic status, ethnicity, and gender. In this talk, I'm going to focus on the unequal or the uneven distribution due to gender, like between men and women. That's the focus of this talk. And the impact of these digital technologies, according to the World Bank, it is mixed, it is uneven, and it's unrealized. This uneven distribution of the gain from digital technologies is rooted in gender inequalities, and more research should be conducted to understand it in its specific contexts. The availability of quality information on digital technologies, like innovations like internet, cell phone, social networking platforms at the subnational level. I will tell you later what is subnational level in this particular study. But the availability of those quality information on digital technologies and innovations and social networking platforms at the subnational level helps us to assist business to become more productive. And it also helps in creating employment opportunities. And the other one is for the government and policymakers to provide better public service. So if there is a digital platform at the subnational level in a sufficient quantity, the government and policymakers would be able to use those social networking platforms to provide some better service, better public service. Now, for example, recently in the US, they're doing Census 2020 in just online basis. So In South Africa, we'll have another census in next year. Maybe, I don't know if they're going to try it online or consider it in the usual manner by going to and counting. So I know there are difficulties to do that in South African context. But Statistics South Africa, Statistics provides a wealth of information for 9 provinces and at the national level, at the South African level as well. Given the sample size at the subnational level is small, a more disaggregated analysis is required to improve the precision of the estimates. Therefore, this research or this study or this talk applies a small area estimation technique, or uses A from now onwards, that can combine survey sampling and population census using statistical models to provide reliable estimates of digital inequality at the 240 local municipality levels in South Africa. So we'll see why I choose local municipality later. What motivates me to use this or to work there? It is a well-known fact that women are seriously underrepresented in the digital economy. According to this source, UNCTAD 2018, they are also poorly funded in this economy. This is a common fact, or just a fact in sub-Saharan African and East Asian countries. In particular, there is a major gender divide in cell phone ownership and internet access. For example, the gender gap in internet access is 16.1% in developing countries and 11.3% in the whole world. The gender gap and in access to the internet in South Africa, I have got one, just this, because our recent census in South Africa is a 2011 census. So according to that census, this is a summary of the digital coverage, especially internet use and cell phone ownership. For example, if you look at the internet use from home, 72.7% of men use internet at home, whereas look how women are underrepresented here. And the gap here is almost 45.4%. And internet use from cell phone, it is better here, especially when we come to women here, much better from using internet from home. So it's the gap still at 16.4. Internet usage or internet access from work, for men it's 66.8, and for women 33.2, and still the gap is there. Cell phone ownership, it is for the men, and this is for the women, and the gap is still 16.8. So especially when it comes to, there's a huge gap in internet use. In fact, this is, we can say it's 10 years, almost 10 years ago, in 2011. So there's a lot happened after that. But still it can give us some evidence about that thing.
So I have a question. If you could go back to the statistics. So is this percentage in total population or of total population or?
A total population. It's a census, yeah.
But it looks to me a bit strange that 72% of men in total population access internet from home.
Yeah.
And that was in 2011. That's quite high percentage, given that, as you show below, 58% have cell phone. So I suspect that only share of these people use internet, and there's no other mean of using internet from home for most people than using cell phones. So 72% of men using internet from home appears to be, to me at least, at the level of like well-developed countries with very good internet connectivity?
That's a good question, but I think this is among the
Oh, I
internet
understand.
users.
Okay.
It is not. It
Okay.
is not like 72% of the main South African men use. But when we consider the internet coverage at home,
I understand. So it's not the population that's
yes,
among internet users. Now I see, because men and women add up to 100. Now I see.
yes, yeah, yes,
So
yeah,
this
yeah.
is the share that among internet users at home that are men
That's
and
true.
women, and the
That's
same with
true.
respect to ownership of cell phones. Okay.
That is true. Yeah. Okay. Thank you.
It would be interesting, I don't know whether you can provide the statistics here as well. What is the percentage of people that use internet from home in total population? Because in 2011, I suppose this wasn't very high. I suspect that was rather low in 2011.
Yeah, but I will check that one. But I only got this information from there. But I will just check and see the total proportion of internet users in among the population. I will check that as well. It's a good comment. Yeah.
Thanks a lot.
Okay, it's a pleasure. I would like to, again, just as further motivation, the time that we're in it's a very difficult time due to the COVID-19 pandemic. And there is an increasing use of digital technologies. There has been an inevitable surge in the use of digital technologies due to the nationwide lockdown and social distancing norms. As you all know, we're forced to adjust to a new ways of work and life. So there's an increase in the use of digital technologies, especially in the leading firms, in educational institutions. So we're working from home. We're using video and audio conferencing tools, especially in the academic or in the in the schools, higher education, college, universities. We suddenly shifted our mode of transaction from face-to-face to online. So using me, even been using Zoom to lecture my undergraduate and postgraduate students, and schools as well. My daughter has been using WhatsApp means of communication to communicate with her teachers when we were in a totally lockdown. So education sectors use video conferencing platforms like Zoom, Microsoft Teams. Still, the technology infrastructure is an issue, and we have seen, personally, I have observed this, because when I post a test, or I usually receive a lot of students, we couldn't access this because of network problem, because of this, because of the electricity issue. So the infrastructure is still a problem in the developing world like South Africa. So there is a need to address the consequence and cause of the digital divide, in fact. And what is a research question here? This research provides local municipality estimates of digital gender divides in South Africa. So it's mainly focused on the difference between men and women's access and use of ICT. What is the contribution? This article contributes to the literature by analyzing the difference between men's and women's access to and use of ICT. I will briefly explain the data source. I will use a 2016 community survey and the 2011 population census together by using a small area estimation technique. But let me specify or focus like for a few minutes, what is small area estimation? Because this is a methodology that I'm going to use to combine the 2016 community survey with the 2011 population census. So in many countries, including South Africa, sample surveys are designed to produce estimates of parameters for planned domains. Domains can be defined as geographic areas or socio-demographic groups or other subpopulations. And the sample sizes are calculated in such a way that survey estimators of parameters for each of the planned domains achieve on a priori fixed precision. They plan to get some, they plan when they design the sample survey, they just plan to get a precise estimate at the planned domains. For example, these are some of the common surveys in South Africa: general household survey, diverse statistics and activity surveys, living condition survey, victims of crime survey, and there are so many surveys. The main aim of this survey is to provide estimates at the national and provincial level. And after that, they produce national and provincial level, and then you can say they are use and throw after that. What these estimation, small area estimation techniques give us a platform to go down at the lower level. Let's say at the district municipality level, or at the metropolitan or district municipalities or local municipalities. Even you can go down to the ward level. That's the lowest administrative level in South Africa. So in this seminar or in this study, the aim is to provide estimates at the local municipality level, because all the surveys are planned to provide at the South African level and the 9 provincial level. They're not planned to provide even at the metropolitan and district municipality level, at the local municipality level. So you can combine data and get the more precise estimate at the lower geographical level. Why local municipalities? The spatial unit closest to communities for the location of many basic service and infrastructure in the local municipalities and local wards in South Africa. Thus, providing information at these levels is a key consideration for service provision and planning and targeting of efforts to reduce, let's say, poverty, to reduce digital inequality, to reduce unemployment, to reduce, let's say, food insecurity. You can do so many things at the lower if you have a targeted effort at the local municipality level. So the aim is to identify the local municipalities with larger challenges. In this particular case, which local municipalities have the highest digital inequality. That is our aim. We need to identify at-risk municipalities using this technique. So when we say unplanned domains, as I say, in practice, estimates of socioeconomic indicators are often required at unplanned domains. It's a district municipalities and local municipalities to offer targeted solution. As I said, sample size in the unplanned domains. When we go down in the South African context, if we go down to, let's say, the surveys are designed to produce at national and provincial level. If we go down, let's say, at district municipality level, the sample size do not allow us to get at precise and reliable estimates. So we cannot conduct a new survey to increase the sample size, since it's too expensive due to time and cost considerations. So this small area estimation approach gives a solution to this problem by introducing model that borrows strengths from other areas and variables. So what is SA? Small area estimation is a part of the statistical science that links survey sampling and finite population inference with statistical models. When we say that small area estimation, the word small refers to sample size of the domain rather than to the geographical size of the domain or the size of the domain's population. So when we say small area estimation, we are referring the sample size of the domain. So there is a brief review of, an excellent review of the small area estimation. It's been provided by these experts in the field. So this SA small area estimation is designed to combine auxiliary information with data from the survey. So when we say auxiliary information, these are information that refers to data sources that have a wider coverage. In our case, where I just obtained auxiliary information from the 2011 census. That's census has a wider coverage than the community survey. There is a demand, a global demand of small area estimates at the local area level. Let's say there's a growing need for population estimates at the small geographical area level for use in regional planning and policy and decision making. For example, if we have a poverty mapping for a country or region for targeting disadvantaged areas and the evaluation of geographically oriented actions and programs. I'm working with my student, we're just doing a poverty mapping at the local municipality level in South Africa using the IES data and census data as well. Demand from the private sector has also been increased because business decisions, particularly those related to small business, rely heavily on socio-economic and environmental and other conditions. So based on the level of auxiliary information available from secondary data sources, small area estimation models can be divided into two. The first groups of models are unit level models. These groups of models need an individual level data. These are the models which are proposed by Bates and Ethiopia in 1988. They use this model to produce or to estimate the county crop areas in the United States using survey and satellite data. So this unit level models relates the unit values of a study variable to unit specific covariates. In many practical applications, it's very hard to retrieve information at the individual or respondent level due to confidentiality concerns. It is, now I got this data from Statistics South Africa, but the aggregate data, not individual level data. If I want the individual level data, I will not get it because of the confidentiality concern. So we have another model, the Fay-Heriot area level model.
So
this
I have
model
a question.
deals with, yes?
Can I ask a question? So you
Yeah.
said that the census 2011 data is, can you remind how many individuals it concerns? Is it 10% of population or?
10% of the population.
So it will be about 5 million individuals in 2011.
Yeah, it's around that, yeah.
And
yeah.
the data is not available for 5 million people individually, or is it?
No, you can find that from the census. But the problem from the census data is you cannot find the detailed information. Like if we let's say want income related variables, expenditure related variables, most of the census variables are demographic in nature.
Right.
Yeah, that's the reason. So you want to combine with, but in surveys, there is a detailed information, but the sample size for the survey is small to go to the the subnational level.
However, I'm asking because recently myself also I tried to access the census data, and I found it on the website of Data First at University of Cape Town, right? And now I don't remember, but I thought that it includes about 1.5 million individuals. That's what I thought, but maybe I'm incorrect. So I'm just wondering, because as you say, so there's confidentiality issues. So there would be probably no information about where these people live, right? But I wonder whether this is available on individual level, like for millions of individuals that you have socioeconomic information and maybe also where the people live, or this is confidential. This can be only aggregated.
I think you can find you even that 10% of the census, you may find the data even at the up to ward level, like local municipality, district municipality level. But if you want to consider one of, let's say, one individual there.
Right.
You don't know who that person is. It's still giving a code. Those codes, if you're walking to StatSA or to the government office, you might have that access to go and trace that particular individual. Otherwise, there is a code, definitely, and you don't have any idea who that person is.
But you see information for this person, even though you don't know where this person lives or something, right? Like you see age, statistics.
Yeah.
Okay, I see. Right.
You can find all those informations are there. But the problem which comes is specifically when you consider surveys. The survey, you're getting aggregate information there, not detailed information. Just you have, if you cause, for example, the household, let's say the welfare and household survey or the labor force survey, you get an aggregated data, not unit or individual level data. For the census, it looks different, yeah, still.
All right, thanks.
Yeah.
That's all.
So for in this talk, this Fay-Harriott model it's an area level model which use an aggregate data. That's why we use this model. There's a detailed explanation about this model. Let's say, suppose Y represent a direct survey estimator of data for local municipality I. So this is our problem of interest. Like, for example, if we want to know a proportion of women as local municipality who are using internet or who own cell phone or tablet phone, that is simply theta I. This is the parameter that we want to estimate in this case. This part can be obtained from the auxiliary information from the census, and VI it's a random variable, the area specific random variable that can be still estimated using different techniques. I will deal about that. I will briefly say about that. So this model, this Fay-Harriott model has two levels. The first model is a sampling model, and the second one is a linking model. Linking model it's just a model which links the sample survey with a census. So we have DI it's a variance of the direct estimator. What is direct estimator? The direct estimator is an estimator that we can obtain from the household survey. And sigma square V is a variance of VI. VI is, as I said, it's a random effect or the random component part here. So level 1 and level 2 models are based on the sample survey and the borrowed strengths component. So you can combine both models in this way. This is a very simplified linear mixed model. Y is equal to xi beta plus vi plus ei. This, as I say, this vi is a random effect, area specific random effect. Ai it's a sampling error. So this is their assumption as well. And one important assumption to make our life easier is we're assuming vi and ei independently distributed random variables. And there are, look here, there is beta. We need to estimate beta, and the variance of VI should be also estimated sigma square V. So we have two known parameters here. There are different methods of estimation which are proposed in the literature. Method of moments by Fay and Harriott, 1979, Prasad and Rao, 1990, maximum likelihood and restricted maximum likelihood in 2000. For example, if we consider the Fay-Harriott moment estimator, we need to solve this equation iteratively to find the estimates of the sigma square V. And beta can also be obtained using solving. After we solve sigma square V there, we can find beta as well. After we get that, we'll have the empirical based linear unbiased estimator. This is a part that we want to obtain. This is like the model-based digital inequality. You can say model-based proportion of women who use internet, proportion of men who use internet, proportion of men who own cell phone or tablet. So this is a model-based. Y is coming from the direct survey, or from the, it's a direct estimator that we can obtain from the household survey. And XI beta is, it is called a synthetic estimator we obtain from the census 2011. What is gamma I? Gamma is this one, we call it a random weight, or sometimes they call it a shrinkage estimator. So this gamma is dependent on the sampling variance and the variance of the random effect. Sometimes this variance of the random effect can be negative. And in that case, look, if sigma square V is negative, these experts in the field, Prasad and Rao and other researchers in the area, they truncate it to 0. If we put the value of 0 when it is negative, there is a possibility to get negative estimate. One thing is due to misspecification, and the other one, if you are working with proportion, and if those proportions are approaching to 0, like a small in nature, obviously we'll have a negative sigma square V. So if we truncate that to 0, this weight will be 1. If this weight is 1, theta I beta is going to be the synthetic estimator. So we're just ignoring the household survey, and we're only considering the synthetic estimator from the census. In fact, one of my area of work is to propose an estimator, an alternative estimator. We proposed with one of my old colleague, we proposed another alternative estimator without truncating this, and that is another issue. I will not talk about that here. And the other alternative model, I'm almost finished the methodology part. I'll come quickly to the application part as well. A spatial Fahey-Heroth model. The Fahey-Heroth model that we earlier assumes that the neighboring small areas, in our case, local municipalities are spatially uncorrelated. However, there are movement of people, movement of economies from one local municipality to another local municipality. So it is just ideal to assume the neighboring small areas, neighboring local municipalities are spatially uncorrelated. They do have a correlation. So I just consider the spatial Fahey-Heroth model, which is proposed by Salvati 2004, which can be defined this way. And rho is a spatial autoregressive coefficient. W is a spatial proximity matrix. I have 214 local municipalities. So I have 214 by 214 matrix of spatial proximity matrix, which that indicates whether the small areas are neighbors or not. So this is a spatial empirical based linear unbiased predictor based on the spatial Fahey-Heroth model. And the other one is, again, we have to assess the uncertainty of the estimates using mean square error. So this is a mean square error, for example, based on the restricted maximum likelihood estimator. What is the first part? The first part is the part of the uncertainty when we assume all the variables are known or assumed to be known. The second part, G2I, is additional uncertainty when we estimate the regression coefficient beta. And G3I is it's additional uncertainty when we estimate the random effect VI. So I will just a detailed explanation of all this estimation and parts are there. And again, since I'm using proportion, I have to do some log transformation because this is still a linear mixed model. Since the relationship between the target variable and the auxiliary variables is nonlinear on the original scale, so I've considered a log transformation following Neves, and this is again another recent literature here. So this is a log transformed, and we have got the transformed empirical best linear unbiased estimator. Again, for the sake of interpretation, we have to get back to the original scheme, back transformation. So it is suggested a biased corrected back transformation, which is suggested by this group of these researchers. They're here, so we still use that part. Now let's talk about the methodology, data source, as I said, the 2016 community survey. So the target variables were drawn from the 2016 community survey conducted by Statistics South Africa. And the auxiliary variables are taken from the 2011 population census. So as I said, around there are, in this part, I have just considered around 40 covariates, 40 auxiliary variables were selected from the 2011 population census to consider for the modeling. These are some of the variables: gender in 2 groups, male and female, race in different groups, age, employment status, employment sector, marital status, education level, different education level, income, a different income level. These are all the variables that we obtained from the 2011 census. Out of these variables, suitable covariates were chosen using correlation analysis. I've done correlation analysis first, and followed by stepwise regression analysis to choose dimensions of the variables to find more significant variables. Let's say first the correlation analysis was run to determine, for example, if one of the covariate, let's say unemployed category, has reasonably good correlation with, let's say, a proportion of female internet users. Such assessment was replicated for all target and auxiliary variables. Now these are the variables are selected for further analysis. For proportion of male internet users, proportion of female internet users, I have 6 response variables. And for each response variables, there are covariates, there are auxiliary variables selected for further analysis. Now after that, the results of the significant association between the covariates and the response variable warrant for modeling the relationship between the 2 sets of variables. So tables represent the parameter estimates. Just let me go and show you. I don't know if you can see, because it's just big when I put the slide in my Beamer slide. So I just take a snapshot and put it this way. I don't know if you can see it. Yeah. So yeah, these are the female internet users, male internet users, female cell phone owners, male cell phone owners, and female tablet owners, and male. It's there. So these are the estimates of the coefficients and the p-values. It's all there. So for example, age category 2. Age category 2 is age group from 15 to 24. Is significant here when you come to female internet users. Yeah, we can interpret it that way here. And education and other, this is a part of the table. And sigma square V, sigma square U, this is a variance of the random effect. All are positive here. So there is no need to truncate and consider the synthetic estimator only, as I said earlier. And the IC, PIC, and the log likelihood functions are also presented here. And
so I have a question about the
other. Yes, yeah.
Can I ask a question? Can you go back to this table?
Yes. Here.
Why is that? So Gen 1, Gen 2, age 5. Why is that these variables are dropped here from the first columns?
Here, look at this proportion of male internet users. These are the variables that I have selected or that I have chosen for further analysis using correlation analysis and stepwise regression.
Right. So you pre-selected some variables in the first stage.
Yes, I have chosen because there are 40 covariates there.
Right.
If I put all the covariates there, it will be like an issue of multicollinearity and other issues as well. To avoid that, according to some literature, they suggest to first to choose those covariates who have just a reasonably good correlation, good relationship using correlation analysis and stepwise regression analysis. Yeah.
Right. So how many observations do you have in each of these regressions?
I think that when we do regressions here, the areas, the number of local municipalities are the number of observations here.
Which would
So I have got 214 local municipalities.
I understand. So in this case, if you would use 40 variables, that would be quite large
Yes,
number of variables relative to number of observations.
Yes, yeah.
However, like, I mean, just one comment, the way I see this estimates is it looks a little bit in a way strange that you run a regression with different set of variables for males and for females, in the sense that because at the end you want to compare males and females, so it looks like it raises a bit of question, is this preselection of variables somehow impacting your results or not? I mean, you say that of course you choose them on the basis of correlation, but it's still like, at least visually to me, doesn't look so nice that there's different set of variables for males and females if the question is related to the differences between both groups. Even if some variables, at least to me, would be insignificant in these regressions. And anyway, they show up, some of them show up insignificant even though they are correlated, right? Then still, I think it looks kind of consistent if the same variables are used for males and females. I mean, that's like my, at least the way I see it. I understand maybe this is a bit different approach because you approach this very statistically, like from, right, but I'm not a statistician, I'm economist.
Yeah,
so
no, I don't understand.
I would like, from economic point of view, I would personally rather see variables that are insignificant in the regression, but that they are not preselected, as not to possibly bias the results by the fact that some different variables are selected for male and female. And as I understand, since the main objective is comparing male and female, then like someone who would review your paper would look first at this and say, okay, like, are you sure you're not biasing the results by making this preselection? So this is just my, like, the
No,
first thing I would see when I look.
It's a good comment. Yeah, it's a good comment. I will just think about it. How can I, maybe even though, as you said, even though it's is no significant correlation and not go through the stepwise regression analysis, I will try to use, if there's a possibility, to use the same kind of variables in both cases and see the result. Yeah.
Right.
I will do that.
I mean, also, like, sort of economically, approaching this economically, like if we would run these regressions, then we would just later say, okay, these variables are not significant, but it wouldn't necessarily, in a way, justify dropping them, just also for, I don't know, for the readers of the paper to see that some variables are not significant.
Okay, yeah, that's good. And maybe the other option to avoid that, I have to think about using the principal component analysis to select similar groups of variables there and fit a model. Yeah.
Right.
Yeah. Yeah. Thank you for that suggestion as well. Yeah. So the other one is just briefly the summary of the estimates, summary of 6 disaggregated estimates on internet access and use, tablet and cell phone ownership. And this is a minimum tablet ownership for male and female at 25th percentile for male and female, the median, the mean, and standard deviation, and 75th percentile. So still, when you come to tablet ownership, males dominate here. Internet, similarly, Girls dominate. Cell phone, yeah, somewhere. Look, this is. I will just briefly go down and see this. There are some municipalities in which females has more cell phone access than or ownership than males. Yeah, and the other one is testing for the digital inequality, and I have taken the difference, and this is a difference between men minus women estimates, and this is a tablet owner, this is internet access and use, cell phone ownership, and this is a maximum difference, and this is a minimum difference, and this is the minimum difference, maximum difference. You see this, there are some local municipalities in which men use 81.3%, the gap or the inequality is around 81.38, and in some municipalities, inequality is 40.37, negative 40. So here, in some municipalities, females use more internet more often than males, yeah. And this is simply the plot, and women, men, this is the first one is for internet use, and this is for cell phone ownership. Here, on average, again, in 2016, females slightly have more cell phone than men. And when it comes to tablet ownership, means more tablet ownership than women, yeah. And I have used two samples to test if there is really a difference or not. And this is a two sample to test for internet use, men versus women. For cell phone ownership, tablet ownership. As you can see, there's clearly a difference when it comes to internet use. Tablet ownership is clearly a difference. Okay, still there's a slight difference when it comes to cell phone ownership. And we have to do also model assumptions because in order to use estimates, we have to still check whether the models, the estimate results are feasible or reliable or not, and used the model diagnostic which is proposed by Brown et al. And this statistic, this is a goodness of fit statistic which tests like the null hypothesis is assume the direct survey estimates and the model-based estimates are statistically equivalent, and to test that uses the statistics, and this is a value of W. And the tabulated value is 256, and this is a calculated value result. So as you can see, all the values are less than this, so we do not reject the null hypothesis. So there is no difference between the direct and model-based estimate. This is one important assumption. The other one is a biased diagnostics. I've just plotted the survey-based estimates and the model-based estimates, and they're expected to be around, to lie around the y is equal to x line. So as you can see here, there is a sharp, all the values lie around the y is equal to x axis. So the bias, these estimates are really, we can say, unbiased. Residual diagnostics, again, I have done the residual diagnostics. These are the distribution of residuals for men internet users, female internet users, main tablet, cell phone owners. So as you can see, these are the distribution. They are more or less randomly distributed. And as you can see, the histograms of the estimates, residuals for the estimates are again symmetric. All the plots are along the 45-degree line. Again, the assumptions of the model assumptions are more or less okay. These are for female cell phone owners and men tablet owners, female tablet owners. And the other thing is, since we are out of, I think the time is going, this is a map of digital inequality. I try to put in the map in the form of map. This part is a difference. I try to put the difference. That's the gap between the men and internet, men internet users minus female women internet users, cell phone ownership between men and women, and tablet ownership between men and women. And as you can see from this plot, more the lighter one is, the yellow one shows is negative. That means women use more internet than men in this yellow parts of this South Africa. Somewhere here, here, somewhere here, so this area. And the more the red one is the one where men use more internet, men has more internet access than women, and men has more tablets than women, and it's something like that. So you can interpret it that way. So this is a very important map, and we can use this map to just, especially for policymakers can use this map, because this is simply gives us a clear visual illustration of estimated local municipality-wise digital inequalities in South Africa. We can get some important where the government should focus to narrow the gap between these municipalities. And I'm just coming to the end of, sorry if I take so much time. What are the recommendation areas to bridge the gender gap in internet access and use and cell phone and tablet ownership? According to, I was just checking World Bank ICT report, and the potential of ICT gains is economic growth, jobs, service. So to achieve gender digital equality and improve the livelihoods of, let's say, millions of South Africans, stakeholder groups such as government, profit organizations, communities, corporate leaders, and individuals should address the following: upgrade women's digital skills, relevance and confidence, provide affordable access, warn and motivate women to take advantage of the opportunities offered by the digital transformation, innovative plans and actions. Finally, as a conclusion, for example, internet usage or by women ranges from a minimum value equal to 9.69% observed at the local municipality of this, to the Northern Cape province, a maximum equal to 70.46% observed for the local municipality of Pashe in the Eastern Cape province. So look at the gap. The gap is 9 some municipalities, 9.69% of women are among the internet users use internet, whereas in some municipalities, 70.46% of women use internet. So this shows that the analysis at the national level does mask important dissimilarities. So when we go down at the local municipality, at the world level, it is easy to identify the municipalities, I can say, at risk or high digital inequality. So we suggest, this is one of the advantages of using the smaller estimation. What is the local policy implication? Local municipality level estimates provide an important piece of information for the government, stakeholder, policymakers for necessary interventions, such as allocate funds, constant monitoring of socioeconomic indicators, such as digital inequality at the lower geographical level is needed to adequately allocate funds and to assess the effectiveness of their spending. So prioritize and allocate resources. The above application helps to identify the marginalized local municipalities. Local municipalities with high digital inequality and low digital inequality. It is possible to identify those, especially the high one, the marginalized one. So this is, I think, a conclusion, and I think thank you very much.
Thank you very much for a very interesting presentation. There's time to ask some questions. Anybody wants to ask something from the audience? If anybody wants to ask, please unmute yourself and ask questions. Or raise your hand. Or you can also, if your speaker doesn't work, you can always type the questions in the chat. Okay, if not, I have some questions. So first, or comments or questions.
Okay.
So first, so as I understand, the statistics related to digital gap comes from surveys from 2016, but
Yeah.
not on individual level of individual or the municipality level surveys, right? But
Yeah.
within each municipality, there was a number of individuals who were surveyed. Do you know these numbers? How many people were surveyed within each municipality?
Yes, I think I have obtained the estimates based on that number. So I can't tell you at the moment, but there's a number is there. Yeah.
Okay, so you yourself derived the estimates of people using
Yes.
internet from individual level information on municipality level in 2016.
Mm-hmm.
Okay, I understand.
Yeah.
So I find this very interesting, of course, that there's this huge gap, and this varies so much across South Africa. And your analysis is very statistically focused so far. So you, of course, highlight the importance of looking at local geographic level in order to identify places with big gap. And you test statistically whether this gap is significant or not. But already, as you indicate in your statistics, the gap is huge. And
Yeah.
there's a lot of variation in the gap across the country, where it changes from actually women using less internet to women using a lot more internet, depending on the area. So in a way, like without even doing any statistical tests, I think one can already clearly see that there is huge gap. And well, I think there's no surprise that statistically you can also validate that there's this gap through different statistical tests. But what I miss here quite a lot, so there's a lot of effort put into this testing, but very little to explanation what is the source of this gap. So it may go back to some cultural aspects, I know, even cultural differences across different regions about the role of women in a household and the relationship between men and women. Like, is this something that the relationship between men and women that makes in some areas women have more internet access than in others? Is it due to economic differences? So clearly these areas where women have more access are actually, I think, poorer areas, right, in terms of income, less urbanized, maybe less education, or I don't know, the quality of education, things like this. So I think there's a lot of aspects that are worth explaining, not statistically, but in terms of interpretation. And this is where exactly your work could be very informative for policymakers.
I agree on that, because I'm a mathematical statistician. I've done even my PhD in mathematical statistics. So that's where I lack this economical interpretation, but I will still, I've got some collected few literatures, recent as well as good literatures, and I will still sit and read and try to fill that gap. But it's just, I admit that's my weakness, even not only in this, when I submit papers to other works, that's where usually I receive a comment. There are so many results, there are so many, you put so many effort, as you said, in the methodology, in the analysis, but economical, the policy implication and other things always lack. So I think I will just consider that. I will definitely read and try to do what I can. Yeah.
Right. Thank you.
Yeah.
Anybody
Thank
wants
you
to
for.
ask any questions? Please feel free to do so. Or any comments? All right. If not, I just have one more comment. So
Okay.
something that you mentioned with respect to, say, publications. And
Request.
yes, please go ahead.
Hello.
Yes, please go ahead.
Hello. Can you hear me?
Yes, we can hear you.
Yes, we do. We hear you. Yeah.
Hello, let's see.
Oh yeah.
We hear you, but it's breaking now. So unfortunately, we didn't hear the question. Maybe you can type in, unless, or you can try again or type in the question.
For the central to in the book. Maybe.
So unfortunately, we couldn't hear the question. Maybe it's if you type in. In the meantime, I just want to make one comment again on what you raised with respect to publication, because I also, when I heard your presentation, I also felt that there's very strong focus on statistical tests for sake of showing the inequality. I mean, as I said, I think that it's already visible on the simple statistic that there's a lot of inequality. So my feel would be that probably should put less effort exactly on the test. I mean, does some basic test, and then much more focus on interpretation, but for which you would need to run, in a way, more complete regressions of this digital divide on different socioeconomic variables to identify exactly like what are the sources driving this inequality. But as such, I find this extremely important. And as you say, there are also World Bank and other institutions, I think they emphasize the importance of reducing digital divide among women and men as one of the factors that can release a lot of economic growth in Africa.
Yeah, thank you. I will definitely do that. I will definitely consider it's a nice and interesting suggestion. I will do. I will just revisit because it's still a work in progress. So I will definitely consider that. Yeah.
Maybe let's see, you can try again to ask a question. If okay, there's a question from Lexi. I can read it.
So I typed what I wanted to ask.
Okay. So the question is, at home, one would think that internet facility serves everybody. What causes this huge gap?
Sorry?
So the question is on the chat to everybody. It says, the question is, at home, like when you have internet connection at home, then anybody can use it, both when men and women, children. So what causes this huge gap? If you have any comment on this.
Maybe I can't say anything because I haven't really done that kind of scientific investigation, but I can just say you were raising, because we're raising like, we're living in a developing world and we know the role of women and men when it comes to the household, and especially if the man or the household, the head of the household is a man, and if the man is the one who is more educated and maybe the source of income, and the woman is doing some household chores there, the caring children and other things, so it might not have an appropriate skill as well as a time to consider and to sit and use internet access, even though there is internet in the household. So, but I will still look for what is the reason. But here, the aim in this analysis that I have done, the aim is just to show the inequalities, and haven't gone then further to see what contributes or to that much gap between men and women. So I'll still read and see what I can find. What are really the causes of that big gap between men and women, especially when it comes to internet usage, gender inequality. It matters there because there's a huge gap according to this data set. So I'll just look at it, but just literally what I'm going to give you is just, it depends. It might come from the role of men and women in the household. Don't know if I can say something since.
Thanks a lot. As you suggest, that's exactly one subject of further investigation. Lenma. Yes, Caroline?
Can I? Yeah, I just wanted to, so just to understand properly, so the data is from the 2016 community, the household survey at the municipality level, the data that you used.
Yes, it's just I have combined two data sets, the 2016 community survey and the 2011 population census.
Okay,
So I've used...
yeah, I was wondering if you looked at the data from Research ICT Africa. Their study in 2017 was, I think, probably the most recent data of this nature that I know about. They also found, for example, that the gap in internet use that you're talking about, and also that the same as you're finding that women have slightly higher ownership of cell phones, but when you dig deeper and you look at smartphones within that, then it changes again, then you find the reverse. So I was just wondering if you looked into that at all. That could be interesting for you. And then also, I'm not sure from your map here if you can see the differences, or if you had all looked at the differences between rural and urban areas, because they found that was one of the biggest gaps in the country when it comes to internet usage. So yeah, just a comment.
Okay, thank you for that comment and suggestion. Yeah, even here, when you see in my case, it's says cell phone, and they put even tablets, and a tablet, when it comes to tablet, the gap is just still very huge. And cell phone, it's in some areas, even though the aggregate level cell phone ownership, it seems women slightly have more ownership than men. But when it comes to in some local municipalities, the gap is still 60 and 70% in some local municipalities. So it's just a good suggestion. I will look for that, and maybe is it rural, is it urban, and I will just definitely check all those local municipalities and see if I can find what the source of this gap, and I will definitely consider that. And thank you for your nice comment and interesting comment.
Thank you very much again. I think we're already over time, so it's unfortunately time to finish this session. And I welcome again anyone who would like to present something at the seminar to contact me. Otherwise, we should have a seminar in 2 weeks from now. So please check the website of ERSA for further announcements, and there will be, of course, email coming as well. Thank you again for your presentation, and good luck with publication of the paper. And of course,
Okay.
other research, which is very interesting.
Okay, thank you very much. I will do that. I really appreciate. Thank you for the opportunity and all the comments, and it will definitely help me to improve this article. So thank you. I really appreciate that.
Thank you very much.
Okay,
Bye.
thank you very much. Bye.